Good day, my viewers. I welcome you to our continuation learning of science and mathematics education. Which subject do we have for us today? We will be looking at physics today, and the topic before us on dimension. I repeat, dimension. In the last class, we talked about derived quantity, we talked about fundamental quantity, where we are saying that fundamental quantity, these are the basic quantity, which other quantities depend on. Example of fundamental quantity, we said is what? Mass. We have time. We have what? Length. We have current and the rest like that, electric current. And we also talk about what? Derived quantities. These are the ones that we obtain. We get them from the what? Fundamental quantity. Either by multiplication, either by division method, whichever way. We get the derived quantity from fundamental quantity. But today we want to look at dimension. What is this dimension? Before we go deeper, I would like us to look at our learning objective, like we normally do in this channel. What is our learning objective? What are the things are we going to learn today in this topic? Now we have on the learning objective, we have what is dimension. We are going to look at how do you get the dimension of different physical quantities. How do you get the dimension, let's say power, let's say what? Pressure, let's say what? Force and the rest. How do you get their dimension? Now, what do you call the dimension? Dimension simply means the power of index, which if fundamental quantity must be raised in order to obtain the derived quantity. The power is the power of index, which if fundamental quantities must be raised in order to obtain the what? Derived quantity. Or in a simple way, it's just a way of relating your fundamental quantity with your what? Derived quantity. Okay, you relate your physical quantity with your what? Fundamental quantity in terms of length, in terms of mass, in terms of time. You use your length, you use your mass, you use your time. You relate them with your what? Derived quantity. That's what we call what? Dimension. So let's put it down. What is dimension? Some people can say that dimension, okay, I say this is the index, by which, okay, the fundamental quantity must be raised, okay, in order to obtain the derived quantity. Or you can simply say that the way you relate your derived quantity to a fundamental quantity. So that's why we say in terms of length, mass and time. That's what we call what? Derived quantity. So this is the power. Let's go. Power of index. Power of index by which the fundamental quantity must be raised in order to obtain the derived quantity. So that's what we are saying. Okay. I want to talk about the physical quantity, derived quantity. That you are talking about what? What do you call it? You are talking about your force, your pressure and the rest. Having said that, so let us look at how to find the dimension of different physical quantity. What do you mean by this? How do you find the dimension of work, dimension of time, dimension of velocity and the rest like that? So let the dimension, basically the first thing, let the dimension of length. These are the basic things. Length have to be what? L. Dimension of mass is what? M. And dimension of time be in what? T. So remember, length, mass and time are fundamental, but you represent them with L for length, M for mass and capital T for time. Is that clear? Now, having said that, let us now look at, this question say, find the dimension. What is the dimension dimension of volume now. Dimension of volume will just be what? We have known the formula of volume. Volume is length times breadth times height. So volume formula is what? Length multiplied by breadth multiplied by height. You want to find the volume of a, let's say, cube now. Length times breadth times height. Okay? And you remember your length is still L, your breadth also L, your height is also what? L. Length is L, breadth is L, and the height is what? L. So L times L times L. Now our volume will now be what? L raised to power 3. So the dimension of volume is what? L raised to power 3. How? L times L times L. Okay? Now let's look at another one. Let us find the dimension of density. Please, the formula of each of these physical quantities is very, very important. You have to know the formula of each of these physical quantities. That's why you are going to use. Now, formula of density, like I've said in the last class, density is what? Mass over volume. The ratio of your mass to your volume. What is the dimension of mass? Mass is what? Capital F. You put it there. What is the dimension of our volume? L raised to power 3. So by the time you combine them together, we have the dimension of L of density now, but L raised to power minus 3. What do you get? Minus, that means 1 all over L cube. So this one stands for 1 all over L cube. You can bring 1 over L cube from this place. So this one also means L m times 1 all over L like this. L is power 3. So this one just means m times L is power minus 3. Now give us this. Okay. So another one. Let's find the volume is in the dimension of velocity. Find the dimension of velocity, that is displacement over time taken. And you know the formula of velocity. Velocity is what? Displacement, the formula. Know the formula first. Displacement all over time. Okay. And what is the dimension of displacement? It's also what? Length. L. Okay. What is dimension of your time? Capital T. So by the time you combine them together, now I have L raised to power minus 1. So this is the dimension of velocity. How do we get this? It means from this place, we have this expression L times 1 all over T, which is equal to L times L minus 1. This one gives us this. So that's how to get the dimension of velocity. What about acceleration? Acceleration dimension. Acceleration will just go. Formula of acceleration is what? Changes in velocity. Velocity all over time. Okay? Velocity all over time. And if you look here, we have succeeded in calculating the dimension of velocity. Velocity is what? L t raised to power minus 1. Just put it here. L t raised to power minus 1. And your t still remains capital T for your time. By the time you combine them together, L raised to power N minus 2. How do we get this? This one means that we have L times L raised to power minus 1. L over what? L raised to power what? Minus 1. So by the time you bring this one, now I have what? L times L, T raised to power what? Minus 2. So that's how we got this one. So that is it. On and on and on like that. I want us to look at force now. Dimension of force. Dimension of force. How do you find dimension of force? So the same way, dimension